we're going to look at domain and range of a continuous relation. Okay? So just pause the video and get somebody to read the little blurb there before the questions in example 2. Alright, we're back. So, we've got a Ferris wheel. I'm just going to draw my best attempt at a Ferris wheel. Here's the ground, and it's got like I guess a thingy coming up here. And there's a big circle that people ride on. How exciting. Okay. The problem told me that the diameter of that Ferris wheel is 193 meters. And the highest point, the maximum height that that Ferris wheel can achieve, which would be up here, right, is 208 meters. That's off the ground. Okay, so 208 meters off the ground is the highest point that the Ferris wheel can achieve. Good. So then they have this graph here which shows the height of a person who starts at the bottom here, and then they go up and up and up and up until they hit the top, and then they go back down to the bottom. There you go. That's $10 well spent. Okay, so you start down here somewhere, and you go up, hit the maximum, come back down, right? Get off and go buy some cotton candy. Alright, so we're gonna, oh sorry, I should add some labels to this diagram here. Add some labels to your own diagram on the one that I drew for you in your notes. This is going to be time in minutes, and the y-axis is going to be height in meters. Okay, time in minutes, height in meters. Okay, we could use the variable t to represent time and h to represent height. Okay, just to make things clear. Also, another thing to note is that the problem said it takes 20 minutes to go around the Ferris wheel. That's going to be important. Okay, so you get on, 20 minutes later, you come back to where you started. So we're going to write the domain and range for this function. You'll notice that it's, sorry, for this relation. You'll notice that it's continuous, right? This is a nice smooth curve with no breaks in it. Okay, and it has lots of meaningful values, right? You could like take a rocket pack and fly up to somebody here and say, hey, it's been like 3 minutes and 69 seconds since you got on the Ferris wheel. How's your ride going? And then the couple on the Ferris wheel kind of looks at you strangely and they're like, good, I guess we've like gone up 56.82 meters. Thanks for asking such a specific question. All right, and then he blasts away and you continue on with your ride. Okay, there are lots and lots of meaningful values in between dots. Okay, in mathematics we say that this line is dense, meaning that there are many values that could be interpreted from this graph. It's not just some specific dots that we have plotted. It's a continuous, smooth curve indicating that there's lots of information that we could glean from this. Okay, so just like we did last time, one of the ways to describe the domain and range is in words. Okay, so let's think about the domain. That's the variable t. What kind of values could t take on? Could it be negative? Could it be positive? Could it be a fraction or a decimal? Well, time, as you know it, is definitely positive, right? When you talk about how long you've been standing somewhere or doing something, you always speak in a positive way. You say, I've been here for 5 minutes, or I ran this morning for 1 hour. You're always talking about a positive value. So time is positive. Could it be negative? Well, that doesn't make any sense, right? You can't go back in time, nor can you say, it took me negative 36 minutes last night to do my homework. That doesn't make any sense. Okay? Time is always a positive value. It could be 0. That would be right here, the beginning of our ride on the Ferris wheel. It could also be a fraction or a decimal, okay? Because we could say, yeah, we were on the Ferris wheel for like 3.6 minutes here, and yeah, that would make sense, right? You could find your height at that point, okay? So the way we represent the domain in this case is we say all real numbers between 0 and 20. All real numbers between 0 and 20. You'll notice that's a little bit different than last example, where I said the domain was all whole numbers between two values. This time I'm saying all real values, all real numbers. What does this word real mean in math? What is a real number? Well, if you remember from grade 9, we had this big, huge chart that told us the different classifications of numbers. We had the numbers that you start to learn in like kindergarten. You've got 1, 2, 3, 4, 5, 6, and so on. These are what we call natural numbers. Okay? They are whole and they don't have any decimals. They're never negative. They're never fractions. They're just whole numbers. Sorry for the moving around here. I'm trying to get enough space for everything. Okay, after that we had whole numbers. This set was all the natural numbers, 1, 2, 3, 4, 5, and so on, as well as 0. That's why I called the domain in the last example whole number, because I had 0 in that set. From there you learned about integers, probably somewhere in grade 6 or 7. Integers, that's all your negative numbers. So there's a bunch of numbers before negative 3 here, and then negative 2, negative 1, 0, 1, 2, 3, 4, and on into infinity. Again, I don't have any decimals yet. All I've introduced now is negative values. Grade 9, you learned about rational numbers. And I can see Sharon grimacing already because she has expressed her displeasure for these numbers, but they're very important. Okay? Rational numbers have kind of 3 definitions. They are either fractions. Maybe I'll just write the word fractions. Fractions, or repeating decimals, or terminating decimals. Okay? And then lastly we had irrational numbers. Irrational numbers. And these were all the numbers that basically don't fit any of these definitions. So they can't be turned into a fraction. They could be repeating decimals, but they never terminate. Sorry, no, they can't be repeating. They're not repeating decimals. They have no pattern to them, and they never end. So examples of that would be like pi is a very famous irrational number. You square root any prime number like 3 or 7. Those are also irrational. There's no like pattern to their decimal. They go on forever, seemingly at random. Okay? All of these numbers here make up a giant set of numbers called real numbers. Okay? And this is the set of numbers that basically you use through K-12 mathematics. If you take mathematics at a higher level, you learn about complex numbers, which are sometimes called imaginary numbers, and I've said this speech a lot of times. Doesn't mean they're fake. They're just different. Anyways, all these numbers that you use in K-12 mathematics are called real numbers. So when I talk about all the real numbers between 0 and 20, I mean all numbers that could be positive, 0, negative, fractions, repeating decimals, terminating decimals, and also things that can't be written in fractions, or repeating decimals, or terminating decimals. So like, think of this as saying every conceivable number between 0 and 20. We're not just talking about 0 and 1 and 2 and 3 and 4 and 5 all the way up to 20. We're talking about every possible number you could ever think of between 0 and 20. So 0.0087 and 9 over 5 and 1.269555 repeating, right? I know these are all strange numbers, but they all are real numbers and they all exist between 0 and 20. Okay? Oh, I think I beat that one to death pretty well. Okay? Domain, all real numbers between 0 minutes and 20 minutes. Range. Okay? This is represented by the variable h. Just think about the numbers that h could be, right? Could it be negative? Could it be positive? Could we have fractions, decimals? Could it be 0? Well, let's go back to our picture here. What's the highest that a person can go on the Ferris wheel? Well, 208 meters off the ground, right? What's the lowest that person can go? Down here. What's this height right here? Well, this would just be the total max height, or the distance from the ground to the top of the Ferris wheel, minus the diameter of the Ferris wheel. Right? If I take this longer distance and I subtract the diameter of the Ferris wheel, I'll get what this little guy is down here. Okay, so this is just 208 minus 193. You just punch that out really quick. That's 15 meters. That's the lowest that the Ferris wheel can go. So if you think about it over here in the graph, down here we're at 15 meters. And we go up and up and up and up and up and up until we get to 208. And then we drop down back to 15 and you get off. Okay? So in this case, can you guess what the range will be? What sentence could we write to represent the range? Well, we know it's a bunch of numbers between 15 and 208. What kinds of numbers? Well, just like we had before, all real numbers. All real numbers. It's important you say that. Real means something very significant. Between 15 and 208. Okay? All possible numbers, every conceivable number between 15 and 208 represents the range in this case.